Alright, so just to finish this one up here, again, if you want to solve for alpha, we can use the point in the first quadrant that we can use 2, 4 basically, making all those coordinates positive. Or again, we can just use the ratios we've already created, just making sure we have no negatives inside our ratios. So using sine, tan, or cosine doesn't matter, you get the same answer. You should get 63.44 degrees. The only other thing to watch for here, which makes this different from the previous ones we did, is because this angle's in quadrant 2, our calculation to find the actual angle, the blue one here, theta, is a little bit different here. So it's 180 degrees for the full, to get all the way over here to the negative x-axis. So 180 degrees minus alpha, the red one here, should give us theta. So we go 180 degrees minus the 63.44 to get 116.56 as our theta. Okay, so moving on. So now something a little bit different here. So I'm going to give you the ratio and give you a possible range for theta, and again, possibly I'm going to ask you to find out all this kind of information. So take a minute and think about it first. What always might help is sketching it, and if you can create a sketch, you might be able to figure out where a lot is. So take a minute and think about this on your own or with a partner, and then when you're ready, we'll talk about it together. Right, so the first thing I'm going to do here, just because I don't like necessarily working with the reciprocal ratios, I'm going to change it from secant into its reciprocal ratio cosine, so that will be negative root 15 over 8. Okay, now, again, I suggested making a sketch of this, so what I'm going to do is I'm going to draw a Cartesian plane, like I normally do here. Okay, now I'm being told that my angle is going to be somewhere between 180 degrees and 360, which means it's somewhere either down in quadrant 3 or quadrant 4. Which one could it be? Are both possible, or is there only just one of them? Well, the key here is the fact that the cosine ratio here is negative. The cosine ratio is negative. Looking at our cast rule, the cosine ratio is negative in 2 quadrants. In quadrant 2 where sine is positive, and quadrant 3 where tan is positive. In 1 and 4, cosine is positive. So it's not possible for this one to be in quadrants 1 or 4 because the cosine ratio would have the wrong sign. So that would leave us between quadrants 2 and quadrant 3, but since we have to be between 180 and 360, the only quadrant we could possibly be in is going to be quadrant 3. Okay, so I'm going to draw this in quadrant 3. Okay, make my triangle here with the x-axis. Okay, and remember that cosine here is equal to the adjacent over the hypotenuse, or x over r. So that means this length right here is going to be root 15 in the triangle. Okay, and the r value, the hypotenuse here, is going to be 8. Okay, so with that, now that I have that, I can actually find the other side in the triangle, because there's a right triangle. I can use Pythagorean theorem. So find this missing side, which is going to be y. So y squared will be equal to 8 squared minus root 15 squared. Okay, so you're quickly running that through your calculator. You get the square root of 49, which is 7. Okay, so we'll put that in there for our missing third side. And then we're off to the races. So now that we have, so putting all that information together, we're actually able to make a sketch of where the angle is located. So theta is going to be in quadrant 3. So that'll be my theta. And my alpha will be the one inside this triangle here with the positive, in this case, the negative x-axis. The nearest x-axis is the terminal arm. So now I can find my primary trig ratio. Okay, so for sine theta, okay, it will be opposite over hypotenuse, so 7 over 8. And again, just always check my quadrant for the sine. So in quadrant 3, the only one that's going to be positive is tan, so sine will be negative. Okay, so cos theta, cosine will be negative because we're in quadrant 3. It will be root 15 over 8. And tan theta will be 7 over root 15. And again, that one's positive because we're in quadrant 3. Okay, so which quadrants could contain theta? Well, the only one that's possible, as we already discussed when we were trying to make the sketch, would be quadrant 3. Okay, and if you want to find an expression for the radial acute angle, we've done this kind of question before. So we did 3 of them on the previous page. So we can use either one of these 3 ratios here. So we could either use alpha being the sine inverse of positive 7 over 8. Okay, again, no negative in there. We could use tan, we could use cosine, whichever one you want. Again, whichever, usually just pick whatever one's easier for you to work out in your calculator. So in this case, you use alpha being the sine inverse of 7 over 8. So now if we want to find theta, we're in quadrant 3. So 180 degrees plus alpha will be equal to theta. Okay, so once we figure out what alpha is, and let's run that through our calculator now. So we'll do the sine inverse of 7 over 8. So that gives me, to one decimal place, 61.0 degrees. So 180 plus 61, we'll throw that into here, should give us about 241 degrees. Okay, so again, this just takes some getting used to, especially dealing with the fact that, again, now we actually have to check our quadrants to check the signs of our ratios. We've never had to do that before this year, because everything we did was inside a triangle, and we didn't have to worry about negative angles or negative ratios. So a couple other types of questions we need to look at here. So here I'm going to give you 3 different ratios, and I want you to give me an expression that's equivalent to it. So to go over something like this, let's just take a look at first at sine 280. And one thing that's always going to help, and I mean always, is making a sketch. Okay, so let's draw the 280 degrees in there. So 280 degrees will be in quadrant 4, because it's above 270 but less than 360. So I'm going to draw that there. There's my terminal arm. And we know this is 280 degrees. Okay, now we should be able to find out from there the related acute angle. The related acute angle is going to show up a lot in this unit, so it becomes very, very useful to try and find that. So if this is 280 degrees, that would mean that alpha here would be 360 degrees minus 280 degrees, so alpha is going to be 80 degrees here. Okay? So if we want to find an expression equivalent to this, so again, one that's going to be the exact same thing if you run it through your calculator, we're going to use this related acute angle. Okay, so think back to earlier on this lesson where we said if the angles are related to each other, so i.e. if they're related to each other, they share the same related acute angle, they'll have the same magnitude. Well, we want this to be equivalent, so we need the ratio not only have the same magnitude, but to have the same sign as well. So let's take a look at our cast rule here. So in our cast rule here, right now sine 280 degrees should actually be negative since it's in quadrant 4 where cosine is positive. You can test that by running through your calculator. Sine of 280 is going to be a negative number. So where else, in what other quadrant is sine going to be negative? Well, the only other place sine is going to be negative is going to be in quadrant 3 over here. So what I'm going to do is I'm going to now redraw this angle, this related acute angle, but now I'm going to put the related acute angle in quadrant 3. So over here I'm going to have an alpha of 80 degrees. Okay, so if that's 80 degrees, what angle here is going to make that happen? So let's just clear this out a little bit here. So if I want this to be, again, an alpha at 80 degrees, let's sketch this in here. What angle is this one going to be right here? So this will be 180 degrees plus 80 degrees, so that will be 260 degrees. So what this is telling me then, because if I have an angle of 260 degrees, it'll give me the same alpha of 80 degrees that the original one does right here, and the signs are the same because they're both in quadrants where sine is negative. Sine 260 should be equal to sine 280. Okay, and you can always test the answer in your calculator. So if you try that, you'll see that sine 260 and sine 280 are identical in your calculator. Okay, so with that in mind, try and do B and C, and then we'll take the answers up when you're ready. So when in doubt, again, just make a sketch to see where you're going. Find out what other quadrant will have the same sign as the ratio that's there, and then you can try and find your related angle from there. Okay, if you'd like to take a quick look at B here, what I did here first off is I sketched 340 degrees in purple here. So terminal arm is in quadrant 4, leaves you an alpha of 20 degrees here with the nearest x-axis. So again, if I want to find a related angle, it's going to have the same alpha. So that could, again, be in any 4 quadrants. However, specifically, because I'm in quadrant 4 here, the cosine ratio is positive. So I need to look at the other quadrant where cosine is positive, which is going to be quadrant 1, where everything's positive. So in quadrant 1, I draw the same related acute angle of 20 degrees. And since it's in quadrant 1, the alpha and theta are going to be the same, so the angle here is 20 degrees. So cos 20 should be equal to cos 340. Okay, and for C, so 115 degrees is in quadrant 2, so I drew that here in black. It leaves an acute angle in alpha of 65 degrees. So to find out what quadrant we're going to go into for an equivalent expression, tan is negative in quadrant 2. So the other quadrant where tan is negative is down here in quadrant 4. So I draw the acute angle 65 degrees in quadrant 4, and I figure out what overall angle will make that happen. So this theta right here is going to be 360 degrees minus 65, so it's going to be 295 degrees. Okay, so that will mean that tan 115 is equal to tan of 295. Again, you can always check if your answer is right with these kinds of things by just plugging them into your calculator. And as long as you get the exact same thing, including the sign being positive or negative, then you know you've got it right. Okay, last type of question we're going to look at here. These are some ratios you want to evaluate exactly, so no decimals, and in theory we shouldn't need a calculator for this one either. Okay, so what we're going to do first is sketch 210 degrees. Okay, so 210 degrees is in quadrant 3. Okay, and if I'm asking you to evaluate this exactly, it should mean that your alpha is going to be one of the special angles we looked at back in the first lesson of this unit. So this is 210 degrees here. My alpha here is actually going to be 30 degrees. Okay, so I can evaluate 210 degrees by using the related angle of 30 degrees instead. Okay, now the only thing I have to check out for here, because again, I know since these are related angles, the magnitudes of the ratios will be the same. I have to check to see if the signs are going to be different. So look at my cast rule. So in my cast rule, in quadrant 3 down here, cosine is negative. Cosine of 30 is normally positive because that's in quadrant 1. So these two are going to be off by a negative sign. So the cos of 210 will be equal to the negative of cos 30 degrees. Okay, and once I have that, to find out cos 30, I can look at my special triangles. So one of the triangles we looked at was a 30, 60, 90 triangle. And by now you should have this one pretty close to memorized. So 30 degrees, we're going to have side lengths of 1, 2, and root 3. So the cosine of 30 degrees is adjacent over hypotenuse, so root 3 over 2. So I'm going to here have negative root 3 over 2 for my final answer. Okay, so again, you'd only be able to evaluate this exactly if the related acute angle was one of our special angles from before, so 30 degrees, 45 degrees, or 60 degrees. Okay, so let's try the same thing with B. So first thing I'm going to do with B is first, I hate cosecant. Let's change that into its reciprocal ratio, which is sine. And also, 585 degrees is way too big an angle. It's not even a principal angle. So let's subtract 360 from that to get a principal angle. So 585 minus 360 gives me 225. So it's better to be working with a 225 degree angle instead of a 585 degree angle. It's a lot easier to draw. So let's make the sketch down here. Okay, so here's my sketch. 225 degrees is in quadrant 3. It's between 180 and 270. Okay, so that's 225 degrees. Okay, if you stop to figure out your alpha, you'll see that is going to be 45 degrees. Okay, so it's going from 180 to 225. So we can use sine of 45 degrees, because it's a related angle, to find the magnitude of our ratio for 225. But again, we always have to check the signs. So in quadrant 3, okay, tan is positive, so sine is negative. So sine of 45 on its own is positive, so we have to offset for the change in sign by putting a negative out in front here. So this is going to be 1 over the negative of sine 45. 45 degrees comes from our other special triangle, the 45, 45, 90 triangle, that has side lengths of 1, 1, and root 2. So sine of 45 is 1 over root 2. So I have 1 over negative 1 over root 2. Okay, and again, if I'm going to do through this division, this will be 1 divided by negative 1 over root 2, which is 1 times negative root 2 over 1. So that's all going to simplify into negative root 2. Okay, that's it, that's all. Your homework's there. And again, this takes a lot of practice to get used to. Even students in grade 12 are still struggling with this, and they find troubles in 4U as a result. So it's good to create a solid foundation now. So please make sure you do practice this as much as you possibly can.